Hey everyone, I'm going to work a couple practice problems from Chapter 8 in the gas laws, since we just didn't get much time to do this in lecture. So this problem here is at the very end of the Chapter 8 slides on gases, solids, and liquids. And I'm just going to go ahead and start working this one. It says a gas has a volume of 2.84 liters at 1 atm and 0 degrees Celsius. At what temperature does it have a volume of 7.5 liters at 520 millimeters mercury? So again, the first thing I encourage you to do is always go through and label your problem, label the different variables and see what you have and decide which gas law you need. So the first variable we have is a volume. So I'm going to say volume 1. We know that from looking at the unit. The next variable has a unit of ATM, which is a unit of pressure. So that's our first pressure. Obviously, this is our first temperature. We'll have to convert this into Kelvin in just a moment. And I want to make a big deal about that. Never plug temperature in units of Celsius. Always convert it to Kelvin. And then the next variable given, this is another volume. So we'll say that's volume 2. And then here, our last variable is the second pressure. So we are looking for T2. We don't know what T2 is. So when you look at all these variables, you need the combined gas law, which is P1 V1 over T1. You're going to have this memorized and ready to go, equals P2 V2 over T2. And since we're solving for the variable that I'm going to highlight right down here, I've actually, there's a homework problem similar to this, and I got a few questions on it. And what the common thing that I've noticed is that most people want to try to just move these two variables and then solve for T2. But if you do that, then you're actually going to be solving for 1 over T2, because this variable for temperature is in the denominator. It's in the bottom, right? What I've highlighted in blue is beneath. It's in a denominator position under P2 and V2. So the first thing you have to do is always make sure the variable you're solving for is in a numerator position, that it's on top. You don't want to solve for 1 over T2. You want T2 over 1, which is just T2. You just want to solve for temperature. So here's the first thing you should do. If you're solving, you don't have to do this if you're solving for pressure or volume, because they're already on the top. But if you're solving for a variable on the bottom, the quickest thing to do would be to take the reciprocal of both sides of the equation. I'm going to say that again. Take the reciprocal of both sides of the equation. Okay, so we're going to flip this side and we're going to flip this side. One common mistake is I'll see students flip one side without flipping the other. All right, so when we do that, what do we get? We'll have T1 over P1 V1 equals T2 over P2 V2. All right, now we can solve for T2. So we're just going to move P2 and V2 by cross multiplying. Why are we multiplying? Because they're on the bottom. And the only way to get them to cancel is to multiply them on both sides. So when we do that, if we clean up our equation, we are left with this new one. I'll just write it over here, T2. Well, actually, I'm going to write it like this. P2 V2 times T1, so these are all in the top, divided by, on bottom, P1 V1, okay, is equal to T2. All right, so we have a correct equation now, and so I'm gonna get rid of everything above this because I need some space. All right, now, before we can just plug everything in, remember you always have to make sure that your units for volume and pressure match and that your temperature is in Kelvin. So our first temperature is not in Kelvin, so I'm going to take 0 degrees Celsius, add 273.15, and T1 is going to be equal to 273.15, so I'll plug that in a minute. Secondly, our second pressure here does not match units of ATM. So we're going to convert 520 millimeters mercury to ATM. So the conversion is, and you'll also have to have this memorized, 760 millimeters mercury for every 1 ATM. okay? And so millimeters mercury will cancel. And when you do that, I believe you get 0.684, and now we have units of ATM. So these are the two things that I will plug in along with my volumes. All right, so we're going to start right here. We'll say P2, which is now the 0.684 ATM, times V2, which was 7.5 liters, times T1, which is 273.15 Kelvin. This is all going to be divided by P1, which is 1 ATM, times V1, which is 2.84 liters. So let's check our units. Always do this. Liters on top, liters on bottom, they cancel. ATM on top, ATM on bottom, cancels. All we're left with is Kelvin, which is good because we're solving for a temperature. So we don't want that one to cancel. All right, when we do all this, let me plug it in. I got that our temperature, T2, is 493.55 Kelvin. A very, very, very hot temperature. All right, hope that's helpful.